Hello and good evening to all of you. Am I audible? Am I audible to all of you? Am I audible? Am I audible? Okay. So, what are we going to do today? In this session, we'll try to cover. Hello, Shyam. Hello, Shyam. Am I audible? Yeah, hello. Okay. So, what is the agenda today? Is that we'll try to cover this topic defense technology. So, defense in defense technology, we'll also try to cover not only defense technology, but we'll also try to cover the topic of IPR. So, these topics we had not touched upon in previous classes. So, we'll look at this topic also, defense technology. What is the importance of this topic in your prelims this year? So, those who are writing prelims this year, so this topic is yes important. Even those who are not writing this year, for next year also, this topic has improved or it has increased its relevance. So in 2014-15 they used to ask questions on defense technology, like they have asked question on what is Agni 4 missile, and is Agni 4 an ICBM or not. So they have asked questions based on some of the concepts of missiles. But surprisingly, for 3-4 years there was a lull period with respect to defense technology. So UPSC did not ask questions on defense technology from past 3-4 years in your prelims. But from last year there has been a change. In fact, in prelims they asked one question related to missile, that is fractional orbital bombardment system. We'll see that question also. And in mains also they asked a question. So in mains they asked this question, that S-400, what is S-400 and why it is considered to be the world's best missile defense system. So you had to compare S-400 with other such missile defense systems. So like the in USA you have this THAAD, or in Israel they have Iron Dome. So you had to compare with that. So how will you be able to answer such questions? S-400, only when you know the basics of missiles, then you can tell about missile defense technology. So we'll try to cover all these topics today, and if time permits in the last part we'll also cover IPR. So when we talk about defense technology, what we have to know, or the what are the areas that we have to focus upon. So in defense technology, the focus area, what do we need to understand in defense technology? The three main important areas that you have to understand is, what are the assets of army, what are the assets of your navy, what are the assets of air force, So in these broad areas we'll try to understand this defense tech. So defense tech you can broadly understand in these terms. So in assets of army, what are the assets? So missiles, yes, it is being used by all they are being used by navy also, by air force also, but we'll study it under in asset of army itself. In missiles are in defense technology, missile topic is the most important one. Why? Because they have kept asking questions based on your understanding of missiles. So they have asked questions related to, like, what is Agni 4, or they have asked what is this S-400. So they have previously asked some understanding with respect to BrahMos also. And in in when we try to understand BrahMos, the concept, the one of the concept involved is that with respect to MTCR. So because of MTCR, India was not able to increase the range of BrahMos and the payload capacity of BrahMos. So we'll try to understand what is this MTCR and how it restricted the development of our missile technology. And in response to that, we have our own missile defense in our own indigenous system also. So in missile, what we'll be studying mainly that what is this cruise missile, what are cruise missiles, what are ballistic missiles. So you would be aware about this. So we'll just cover the basics also, then we'll move to the detailed aspects or the technology aspect, and then we'll also look at the Indian guided missile development program. So in IGMDP only, that we are developing Agni missile, or you would be hearing about Prithvi, Trishul, Akash or Nag. So under integrated guided missile development program only we are developing Agni. And BrahMos is a joint venture between India and Russia. So we'll try to understand how is BrahMos, what is the difference, let us say, between BrahMos and Agni. So these are basic things that you should be knowing, that what is the difference between BrahMos and Agni. So we'll cover missiles here, and in this only what we'll try to do is that with respect to MTCR, there are other things that you should be knowing, that is what is this MECRs. So MECRs, there are 4 MECRs. So there is this NSG, there is this Australia group, there is this MTCR, and there is this Wassenaar agreement. So we'll try to develop an understanding of all these MECRs. So a prelims question could be like, is India a member of MTCR? Is India a member of NSG? What is this Australia group? What is Australia group about? What is this Wassenaar agreement about? So these are prelims areas. So we'll try to develop understanding of these things also. Then we'll look at missile defense system. We'll look at missile defense system, or they are also famously called as air defense system. So in this we'll look at S-400 and we'll compare them, let us say, with the US THAAD, or we'll compare it with Iron Dome. And India is also trying to develop its indigenous air defense system, that that is given in the slide. So there we'll see it also. So here we'll try to cover S-400 also. Next, in Navy, what we'll do, in Navy we'll try to cover what the assets of Navy. So the most important asset of Navy is the aircraft carrier. So aircraft carriers are in news. Why aircraft carrier is in news? It is because last year India commissioned the first indigenously developed aircraft carrier, that is INS Vikrant. So with respect to this, you should know some specifics about INS Vikrant. You should also know that India not only has this INS Vikrant, but India also has INS Vikramaditya. So that also we'll try to cover. The other assets of your Navy are your submarines. So submarines are broadly categorized into 2 types. Submarines are broadly categorized into diesel submarines and nuclear submarines. Diesel and nuclear submarines, it does not mean that diesel submarines cannot carry nuclear weapons. It is not about what they can carry, it is about what is the source of energy or what is the propellant system. So in nuclear submarines, nuclear power is used to drive the submarines. So India has only one nuclear submarine, INS Arihant, and India has 15 diesel submarines. So we'll develop a basic understanding of these diesel submarines also. So that in diesel submarine, India is undergoing one project which is known as Project 75. This Project 75, you should have a basic idea of this Project 75. Okay, hi Dharamveer, I am from GTB. Okay, Dharamveer, I recall you. So you are a Sriram student, I believe. So you are my batch student, I guess. Okay, in assets of Air Force, what we'll do is that we'll try to cover mainly the drones part. So because government has come out with new drone rules, new drone policy, so we'll try to develop a basic understanding of this also. In diesel submarine, in the assets of navy, we'll also cover some of the warships also. So with respect to warships, so there is this project 17. So we'll try to understand what is this project 17b, what is this project 75. In project 75 only, you would keep hearing that we are developing ins, what Khanderi ins, Karanj ins, very recently all these ins, Villa, Vagir, Vakshir, they were in news. So we'll try to just have a overview of them. Okay, so what we'll do, we'll begin from the understanding of our missiles. But before we begin with our understanding of missiles, so let me just add one more slide here. See, with respect to defense sector, with respect to defense in defense sector, there is a famous report which is released by SIPRI. SIPRI, what is SIPRI? SIPRI is Stockholm International Peace Research Institute. So SIPRI is Stockholm International Peace Research Institute, and it often comes out with defense related data and reports. So in defense sector, it says that India is the largest arms importer in the world. India is the largest arms importer in the world. Largest arms importer in world. In some reports, you would see that India is second. So this SIPRI report, that it is saying that India is the largest arms importer in the world, and the out of the total imports, or when we look at it globally, out of the total global imports, India's contribution is how much? India's contribution is around 17% of all the arms import which is happening globally. India contributes 17%. So India is the largest importer in the world. If you look at the arms export in the global arms export, if you look at the mix, then India's contribution is just 0.2%. India's contribution is just 0.2% in the total global arms export. So can you see here that India is majorly an importer of the arms, and the contribution of Russia, so of Russia has decreased over a period of time. So in 1990s, of all the sorry so just cut out this one. In 1990s, of all the arms imported in India, so around 60% would be from Russia. But now if you look at the arms imports, so this has dropped down to around 45 to 46%. It means that India is importing not only from Russia but from other countries. So obviously some other countries have started contributing to India's arms import. So you know the names, yes, USA and Israel, they have taken up the mantle. Okay, so with respect to defense sector, India is the third largest country in terms of defense expenditure. Defense expenditure, it means that out of the GDP, how much percentage are we spending? So India spends around 2.6% of its GDP on defense. It spends hello all. India spends 2.6% of its GDP on defense. If you look at USA spends around 3.4% of its GDP on defense, and Russia, USA is the first, China is second. China spends around 1.7% of its GDP on defense sector. India is the third. So here we are talking in absolute numbers. So in absolute number, India is the third country which is spending 2.6% of its GDP on defense. So India is, according to this report, India is the largest arms importer in the world. So this is the basic background of our defense sector. So let us begin with missiles. So in missiles, what do we need to cover, or what do we need to understand? See, missiles, you can broadly categorize missiles into two types. So missiles are one missile is cruise missile, the other missile is known as ballistic missile. So let us look at these missiles through examples. Any example that you know of cruise missile? Any example of cruise missile? Yes. Any example of cruise missiles? Nag. Okay. Which is the fastest cruise missile of the world? Yes, BrahMos is the fastest cruise missile of the world. Any ballistic missile that you know? Yes, Agni and Prithvi. These are your ballistic missiles. Can you tell me the difference between cruise missile and ballistic missile? So cruise missile, the uniqueness about the cruise missile is that, let us say if this is Earth, and this is the atmosphere, this is the outer layer of the atmosphere. Let us say this is your Karman line. What is Karman line? What is Karman line? What is the Karman line? So Karman line is about 100 kilometer. It is the boundary of our Earth's atmosphere. Yes. So after this, space starts. So any cruise missile that is launched, let us say from A, and it has to reach to point B. So it will launch, it will fly, and then it will fall or hit the target. So it always remains inside the Earth's atmosphere. Cruise missile always remains inside the Earth's atmosphere. But if you look at ballistic missiles, if this is your Earth and this is the Karman line, then if a missile is launched from here, it will reach space and then it falls back to a particular point. So this trajectory, this is a parabolic trajectory. This trajectory is known as ballistic trajectory. So they leave Earth's atmosphere. They leave the Earth's atmosphere. So they are leaving the Earth's atmosphere. So can you tell the difference then? If the difference lies in the trajectory, here the difference would be what type of engine we'll be using. See, a missile is what? Unmanned. A missile is just like a flying bomb. The idea of missile had developed as a flying bomb itself in World War II by Nazi Germany. So they thought that why not develop a remote piloted bomb. So the idea has evolved from that remote piloted bomb to become what? To become these autonomous systems. In these autonomous systems, what is happening is in autonomous system, what is happening, that you once need to fire them and after that you need to forget. So they will follow a particular trajectory and they will hit the target. So that is the objective. So in cruise missile, what is the idea of the cruise missile? So because they remain inside the Earth's atmosphere, it means that the engines that they will be using, they will be what? They will be like normal jet engines. They will be like normal jet engines, or they could be using ramjet engines, or they could be using scramjet engines. And here we are using what type of engine? We are using a rocket engine. Do you know the difference between a rocket engine and a normal jet engine? Do you know the difference between jet engine and rocket engine? Yes, can you tell the difference between rocket engine and a jet engine? A jet engine uses what? Air. It uses air to burn the fuel. But a rocket engine, they carry their own oxidizer. So as to burn the fuel. Okay, so a little later we'll look at the technical. If you want, we can go for further explanation of what is the difference between, let us say, a jet engine and a rocket engine. That we'll see a little later also. So the basic difference between cruise missile and ballistic missile is the trajectory, and because of the trajectory, here the engine that we are using will be using such engine which intakes air, and here they cannot get air when they are moving out in space, so they need to carry their own oxidizer. And what happens in the later part, so they will reach to some height. It reaches generally to a height of around, let us say, 2000 kilometers, and from here it starts to fall. So because of the intense height, because of the potential energy that it reaches, when it starts to fall, it gains a lot of speed, and it reaches speeds what is known as hypersonic speed. So when it enters the Earth's atmosphere, it could even reach hypersonic speed. What do you mean by hypersonic? What is hypersonic? What do you mean by hypersonic? See, these terms you'll keep hearing in defense technology. So something as Mach 5 or higher, yes. So hypersonic, it means that it should be traveling at speeds greater than 5 Mach, or 1 Mach is what? 1 Mach is referred to as speed of sound in air. Speed of sound in air. So if something is traveling at speeds greater than 5 Mach, it is called as hypersonic. If it is traveling between 1 Mach to 5 Mach, it is called as supersonic. If somebody is traveling less than speed of sound, then it is called as subsonic. So your commercial flights, they are subsonic, your fighter aeroplanes are supersonic, and your ballistic missiles can reach up to hypersonic speeds. Even S-400, that we'll see later, is also hypersonic. And with respect to the range, Range means to what length they can go. The range of cruise missiles are not very high. At max they can have a range of around 500 kilometer. In some cases we can increase it to, let us say, 700 or 800 kilometer. But in case of ballistic missile, the range is very high. It can go from as short as 300 kilometer to as high as 12,000 kilometers, to as high as 12,000 kilometer. And if a missile, if it can reach a distance of more than 5,500 kilometer, then we call such missiles as what? We call it as ICBMs. We call it as ICBMs. So in India we have only Agni 5 and Agni 6 as ICBM, and Agni 6 as ICBM. That we'll also see, but for now you just remember that Agni 5 and Agni 6 are ICBM, intercontinental ballistic missile. They are called as intercontinental ballistic missile. So if the range is more than this, then a missile can be called as ICBM. And what about the payload capacity? See, the payload capacity of BrahMos, or let us say the cruise missiles, they are less compared to the ballistic missiles. So ballistic missile can carry heavier payloads, and also ballistic missile also have unique quality that they can carry multiple warheads. They can carry multiple warheads. So missiles, this type of missile can carry multiple warheads, and it can start dropping from different heights. So it can target multiple targets. So it can target not only one, but it can target multiple targets also. So this is what is known as MIRV. MIRV is multiple independently re-entry targetable vehicle. So it can target many targets at the same time. So ballistic missiles have that quality. Cruise missiles, they generally carry one warhead only. So the warhead, cruise missile can also carry nuclear warhead. Ballistic missiles can also carry nuclear warhead. It is not that you cannot say that cruise missiles cannot carry nuclear warhead. So this is the basic difference between cruise missiles and ballistic missile. Is this part clear to all of you? Okay, this part we'll see why they were in news. So what we are saying here in this slide, that a missile is an unmanned rocket designed to carry a payload. Payload here is like it is warhead or the bombs. So the bombs can be what? It can be conventional bombs, or it can be nuclear bombs also. So it can carry conventional weapons, or it can carry nuclear weapons. See, the idea of missiles, it had gained traction especially after World War. So in World War, when this Hiroshima and Nagasaki, when they were bombed, so they were not bombed using missiles. In fact, the bomber planes were used. So bombs were dropped on Hiroshima and Nagasaki, and after that there was a realization that it is not the bomber or the plane that dropped the bombs, nuclear bombs. They could have also got damaged because of the waves that are produced because of the nuclear weapon. So the belief is that we should be delivering nuclear warheads only through missiles. So missiles are what? They are carriers. So a country, even if it has nuclear weapons, but it should have sophisticated delivery mechanism. So missiles are acting as a delivery mechanism of your warheads. So that is the basic idea of a missile. They are designed or to destroy the object or the target. So what is their role? Missiles are destructive in nature. Their purpose is not like your spacecrafts. They are doing constructive work. They are sending satellites which are beneficial to humanity, but missiles are not beneficial. They are of destructive nature. But the technology or the systems that you will see in case of ballistic missiles, they are very similar to what spacecrafts also. So we'll see that how they are very similar to even your spacecrafts. The historical background goes that we have already mentioned that during Nazi Germany, so they had developed this flying bombs. So these flying bombs, the idea was that to have flying bombs or rockets. So after this, but what had happened during World War, that they were successfully intercepted by US, and USA soon realized that these bombs have some utility, so they also developed it and they deployed it also. But the real game changer happened with the development of ICBMs, and very recently last year, it is what is the new development is the hypersonic glide vehicle. So you would have come across news that China has developed hypersonic glide vehicle, and after they tested this hypersonic glide vehicle, even Russia tested hypersonic missile, even USA tested this hypersonic glide vehicle. India is also trying to develop these hypersonic glide vehicles. So the next big revolution in missile technology is this hypersonic glide vehicle. So we'll discuss this also little later. So this is the broader classification of the missiles. So IGMDP will do. What is IGMDP? IGMDP is Integrated Guided Missile Development Program. It is the indigenous program of India to develop what missiles. So this program will come. We will come to this program also. So classification of missiles. So broadly you should remember this: cruise missile and ballistic missile. Based on launch mode. Launch mode is what? So a missile can be launched from surface and the target could be in surface. So we are calling it as surface to surface. Here the launching mode or the launch, it could be launched from surface, it could be launched, the target could be in air. So these are known as surface to air. So it could be launched from, let us say, coast, and it could be, the target could be in the sea. So in this way you have different combination. So a missile can be launched from air and the target could be in air. It could be launched from air, the target is in surface. It could be launched from sea, the target could be in sea. It is launched from sea and the target is surface. And then there are these anti-tank missiles. So these are the based on launch mode. Based on range, there are short range missiles, there are medium range missiles, there are intermediate range missiles, and you have these ICBMs. Based on propulsion system means what propels this missile. Propulsion system means what is the fuel, type of fuel that we are using. So we could be using solid fuel, we could be using liquid, we could be using hybrid, we could be using ramjet, scramjet, and in some cases we could also be using cryogenic. So we'll try to understand these later part also. We'll try to see what is the difference between jet engines and your ramjet, scramjet, and your cryogenic engine. Guidance system, it means how they are guided. So they could be wire guided. So wire guided is now like done and dusted. We are not using this. So they could be the most latest ones are this one laser guided, or they are RF and GPS guided. So these are the latest missiles. So these are the different types of missiles. So on the basis, when we say short range means that it should be traveling less than 1,000 km. Medium range between 1,000 to 3,000 km. Intermediate range just 3,000 to 5,500, and ICBMs are more than 5,500 km. So based on range we can classify the missiles. Based on speed that we have seen, so it could be subsonic, it could be supersonic, or it could be hypersonic. Now this difference that we have already seen, this is a ballistic trajectory. So this is a ballistic trajectory and this is a cruise trajectory. See, even in cruise trajectory, the idea here, the cruise trajectory, the missiles, they travel very close to the surface. They do not want to travel at very high altitudes. Why? Because if they travel at very high altitude, they can be easily detected by radars. We'll understand what are radars also, but we fly them low so that they are not able to be, so they are not detected, so they can escape the radar system of the enemy. So they are flown very close to the ground. So these cruise missiles are flown very close to the ground. So this is a basic design of a cruise missile. You just need to appreciate, you need not get into too much technical detail that what is the design. You just need to know that cruise missile is nothing but just like an aeroplane. It is just that there are no pilots sitting here, and instead of passengers there are bombs here. Okay, so you have the warhead here, but the engine Engine is what can you see here? Turbojet engine. So engine just like an aeroplane, but instead of passenger you have a bomb, and instead of pilot you have these autonomous systems. So they are remotely piloted. So this is the basic design of a cruise missile. Cruise missile is just very similar to your aeroplanes, but the objective is destructive. That is the main difference. So the examples of your cruise missile are, this is the American cruise missile, that is called as Stormhawk. Nirbhaya is an Indian cruise missile. The uniqueness about this Nirbhaya is that it is subsonic. It travels at speeds less than 1 Mach. And BrahMos is considered to be the fastest cruise missile. It travels at 2.6 Mach speed. So it travels at 2.6 Mach speed. And ballistic missile. So in the cruise missile, you would have seen that we are using conventional jet engines. But in your ballistic missiles, we are using rocket engines. See, all engines, whether you talk about jet engines or whether you talk about ballistic or rocket engines, they use one principle of Newton or one law of Newton. They all are based on one law of Newton. Your jet, whether you talk about jet engine or whether you talk about rocket engine, they all are based on one principle of or one law of Newton. Which is the law? What is the law that we are talking about? Newton's third law. So your rockets are nothing but just like a balloon, a filled balloon. Let us say if I have filled in air in the balloon, and imagine that this is an inflated balloon, and if I leave this end open, what will happen? The air will move out in this direction. What will happen to the balloon itself? Will the balloon remain stationary here, or will it move in some direction? Yes, anybody? In what direction will the balloon move? Opposite direction. So it will move in the opposite direction. So if you are leaving the end open, if the air is moving out, the balloon will move in opposite direction. So this is known as Newton's third law of motion, that every action has equal and opposite reaction. So now in your rocket, what we have to do? In your rocket, we have to produce these hot exhaust gases. So in your rockets, you would have seen that hot exhaust gases, they move out in this direction, and the rocket then gets a thrust in this direction. So the idea here is that we have to produce lot of hot exhaust gases which can be moved out of the exhaust nozzle. So what we are doing, we are taking oxidizer, let us say in this case liquid oxygen, and we could be using some fuel here. So that fuel and oxidizer, they are burnt in this combustion chamber. So this is the combustion chamber where fuel and oxygen, they combine and they produce lot of hot exhaust gases. Because of the hot exhaust gases, lot of hot exhaust gases are produced. They are thrusted out in this direction, and just like the balloon here, so because the hot gases are moving out in this direction, the rocket moves in upward direction. And why we are carrying its own oxidizer? Because in ballistic missiles, they will move out of Earth's atmosphere, they will reach into space, so they will not get supply of oxygen. So that is why we are using we have to carry the oxidizer also. Are you able to understand this, that how are rocket engine designed? So rocket engines are nothing but they are just carrying their fuel and oxidizer, and they are burnt in the combustion chamber. So here the design that you can see, this is a pipe, here this is a pipe, and through motors the fuel and the oxidizer are brought together and they burn in the combustion chamber. They produce a lot of hot exhaust gases. These hot exhaust gases pass out and they produce a thrust in the opposite direction. Are you able to understand this? that how Newton's third law of motion is applicable in case of your missiles or even in your jet engines. Okay, so this is a diagram just showing you this, the three stage intercontinental ballistic missile, operational range, single warhead, and MIRV 2 to 10 capable. So here you are seeing Agni 5. So Agni 5, what we are saying, that it has 3 stages. So this is your first stage, this is your second stage, and this is your third stage. So what you can see in this diagram, that in the initial launch, so these hot exhaust gases are moving out in this direction, the missile is moving in this direction, then these parts will fall off in the ocean, and eventually what will happen, only the warhead will reach space, and then it will fall back, so it will have a ballistic trajectory. So the differences we have seen, it flies within the atmosphere and it leaves the Earth's atmosphere. Here we are using jet engine, here you are using rocket engines. So these differences we have already seen. Different types of engines. So conventional jet engines, do you know how jet engines work? How do jet engines work? So let me just show you this diagram and how jet engines are also working on the same principle of, let us say, this balloon. So this is a balloon you have filled in air, and if you open up this end, so if the air moves in this direction, so the balloon will move in this direction. So the principle is very, very same. So we are using again here Newton's third law of motion. What is happening here? Air is brought in from the front end, and it compresses the air, and here you can see the fuel is being sprayed. So fuel will burn in presence of air, and hot exhaust gases, they are moving out in this direction. Because they are moving out in this direction, the body gets a thrust in this direction. So this is the mechanism of your conventional jet engines. Also in your conventional jet engine, you would see here fins also, so there is some rotating part. So in your conventional engines, so if you would have traveled through aeroplanes, you would have seen there are fins. Those fins are what? Compressory blades. What is the role of the compressory blade? To compress the incoming air. This incoming air, you are compressing it, so we are increasing the energy density, or we are increasing the amount of oxygen per unit volume. So there is more concentration of oxygen now, so it will burn more, the fuel will burn more efficiently. So because it is compressed, the hot exhaust gases that is produced is also quite large in number, or quite heavy in volume. So more exhaust gases, so more exhaust gases will pass out, so more thrust it will generate. So this is the mechanism of your jet engine. So jet engines are used in your which type of missiles? So they are used in the conventional cruise missiles. But if you have to design something like a BrahMos missile, so BrahMos missile is next, we'll see BrahMos missile. BrahMos missiles, they are using what? This type of engine, or they are using ramjet and the scramjet engine. Is the concept of engines clear? How are engines being used in missiles? And let us now look at cryogenic. So cryogenic you would have seen in space technology also, but we'll refer to this again here. So in cryogenic, what is the difference? So cryogenic engines is an advancement over the rocket engine. Can you tell me what is cryogenic engine? What is cryogenic in cryogenic engine? So we are talking about cryogenic engine. We are talking about cryogenic engine. Is it only the fuel, or is it also the oxidizer? What is cryogenic engine? Fuel is kept at low temperature. Yes, good question. So the fuel Let us say here we are taking hydrogen or gaseous hydrogen initially. If we decrease the temperature to minus 253 degrees Celsius, the gaseous hydrogen converts into liquid hydrogen, and here we are using oxygen. So if we liquefy or cool it to more than minus 180 degrees Celsius, then becomes what? Liquid oxygen. What do you think is the advantage of going to this stage, liquid hydrogen and liquid oxygen? Liquid hydrogen and liquid oxygen. So what happens is that the volume decreases very drastically. Volume decreases by 600 times of hydrogen. It means that now in per unit volume you are packing more gaseous, more fuel molecules, more oxidizer. So when they burn at a very high rate, and they produce a lot more exhaust gases than compared to your conventional rocket engines. That is why cryogenic engines are said to provide high thrust. They provide a very high thrust in your rocket engines. So this cryogenic engines are used. Where is cryogenic engine? In which of the launch vehicles are we using cryogenic engine? Which Indian launch vehicle are we using cryogenic engine? In space technology, do you remember in which launch vehicles are we using cryogenic? Spacecraft. In the Indian launch vehicle, in GSLV, we are using cryogenic. So in your ballistic missile also we can use cryogenic. What is the difference between ramjet and scramjet? See, ramjet and scramjet, so I'll just clarify. See, ramjet and scramjet are very similar to a jet engine only. They are jet engines only, but they do not have in the front the rotatory blades. Those compressor blades are not there. So just the incoming air is compressed, so they do not have rotating parts. So that is why they are called as ramjet. The other one is called as scramjet because the vehicle is at supersonic speed and the air gets compressed at that rate, and so there is no need of compression, rotatory compression. So they are called as scramjet engines. We will come to this IGMDP. Before we come to IGMDP, let me just discuss this BrahMos missile. BrahMos missile, what do you know about BrahMos missile? BrahMos missile. Russia and India have jointly developed. Why the name BrahMos? So it is after the two rivers, one Indian river Brahmaputra and the other Moskova river. So this project started in early 1990s, and initially the range of the BrahMos was less than 300 km. It was less than 300 km. Moskova river. They are named after two rivers, Brahmaputra and Moskova. So initially the range was less than 300 km and payload capacity was less than 500 kg. BrahMos is the fastest cruise missile of the world, and it has two stages. So in the first stage we are using what? Solid engines. In the second stage we are using liquid engine. So it has two stages. And the question here is that why the range was less? Why the range was limited to 300 km only? Why not more than 300 km? Why not more than 300 km? Why the range of BrahMos? Now the next generation of BrahMos that we are developing BrahMos 2, we are developing BrahMos 3. Here the range can even go up to 800 kilometers. But initially the range was less. there is a concept involved. Why the range was less? Because of MTCR. What is MTCR? What is MTCR? Missile technology control regime. Yes. So see, globally there are 4 regimes which are called as multilateral export control regime. So one of the regime is your NSG. So this was formed just after India's Pokhran 1 explosion in 1974. Then there is this Australia group. Australia group was formed in 1985. And then you have this missile technology control regime. This was formed in 1987. And then we have this Wassenaar agreement. So in Wassenaar agreement, this was signed in 1996. So India is a member of Australia group. India is member now of MTCR and Wassenaar also, but India became a member of Australia group in 2018, of this in 2016, of this in 2017. But India was initially not a member of MTCR. So what is this missile technology control regime? Russia was a member of this missile technology control regime. So this regime restricts the export of technology to any non-member countries. So MTCR is a group of countries. Initially it was formed by your G7 countries. But now we have 35 countries in this. India became the 35th member. So initially India was not a member, Russia was a member. So Russia could not transfer any technology which could increase the range of missiles, not only missiles but also drones, increase the range to more than 300 km and payload capacity of more than 500 kg. So because of that restriction, the BrahMos, we were not able to increase the range or the payload capacity. But now, since India has become a member in 2016, the BrahMos 2 and BrahMos 3 that we are developing, they are obviously hypersonic also, and they will be having higher range also, and they would be having higher payload capacity also. So initially India was not a member of missile technology control regime. So what is this MECR? MECR is multilateral export control regime. So these are regimes which are outside United Nations. These are different groupings of countries. So in NSG there are 48 countries. So these countries, they own the technology, or they have access to resources or to the fuel. So NSG, Nuclear Suppliers Group, India is not a member of NSG. So to become a member of NSG, you have to be a member of NPT. NPT was signed in 1968. What is NPT? What is NPT? What is NPT? Non-Proliferation Treaty. So is India a member of NPT? India is not a member of NPT. So NPT was signed by P5 countries, and India had not signed it because it said that it is a discriminatory treaty. So this you would have read in international relations, so I will not delve deeper into this. So NPT was signed in 1968, and after their Pokhran 1 NSG was formed, Nuclear Suppliers Group. So 48 countries are there. So what are these countries doing? These countries do not allow export of some of the technology or the raw material to non-member countries. So India is not a member of this grouping, but India has got a waiver of NSG because of the Indo-US agreement of 2008. do you know about this Indo-US agreement of 2008? What is this Indo-US agreement of 2008? What is this Indo-US agreement of 2008? Yes, it was the nuclear deal. So India has got a waiver that it can get access to technology and fuel, but India has to open up its nuclear power plants for IAEA inspection. IAEA inspection, or they are also called as your additional protocols. So these questions have been asked previously. So what is IAEA? What is this additional protocol? So in additional protocol, India has to open up its nuclear power plants to IAEA inspection. IAEA is International Atomic Energy Agency. It is a UN watchdog. Hello Ram Kumar. Hello. So it is a UN watchdog. So India has to open up its nuclear power, not all nuclear power plants, but out of the 22 nuclear reactors that India has, around 20 of these nuclear reactors are open to this IAEA inspection. So what is this Australia group about? Australia group, the context of this grouping is that during the Iran-Iraq war from 1980s to 1988, so there was a fear that Iran and Iraq would use biological and chemical weapons. So Australia group is about biological and chemical weapons. So you can just remember through this simple mnemonic that Australia group is about biological and chemical weapons. So the grouping in this, so there are 43 countries in this, and these countries they have a list of compounds. So these compounds cannot be exported to other countries, so that it can help in development of biological or chemical weapons. So materials or compounds are restricted to export in the Australia group. This missile technology control regime, it had come during the last part of the Cold War. So last part of the Cold War, there was intense rivalry between US and Russia, which was known as the period of science war also, or both Russia and USA were developing these missiles. So then this missile technology control regime came into existence, and then after the fall of Russia or USSR, this Wassenaar agreement had come in 1996. So there was increased demand now for conventional weapons or dual use technology, so as to restrict the transfer of or restrict the movement of these dual use technology, or to share information. This Wassenaar agreement was formed or done. So Wassenaar agreement is about conventional weapons. This is about conventional weapons. So this is the multilateral export control regime. So we are now developing BrahMos 2 and BrahMos 3 also. So BrahMos 2 and BrahMos 3, BrahMos 3 is hypersonic also. Okay, now coming back to the Integrated Guided Missile Development Program. So what is this Integrated Guided Missile Development Program? So this program had started in your 1980s. In your 1980s, it was started by Dr. APJ Abdul Kalam. So his idea was that India should be independent in case of missile technology also. So India has developed ballistic missiles. So here you can see that Prithvi is a ballistic missile, and this Agni is also ballistic missile. So here it is not just Agni is not short range, it is not intermediate range, but it is from intermediate range to long range also. So these are your ballistic missiles. Agni and Prithvi are your ballistic missiles, and these you can say that they are kind of a cruise missile. So this Akash and Trishul are what? SAMs, surface to air missiles. They are both are SAMs, surface to air missile. It is the difference in the range. So the Trishul is a short range SAM. It is a short range SAM, and this is medium range SAM. So this is your MR SAM, and this is your short range SAM, surface to air. So here it means the target is in the air, to destroy aerial targets, like it could be fighter planes, it could be drones, it could be missiles. So Akash and Trishuls are specifically designed for that. So they are not leaving Earth's atmosphere. they are not leaving Earth's atmosphere. But Prithvi and Agni, they are ballistic, they will leave Earth's atmosphere. Nag is a specific type of missile, very unique type of missile. That is, it is an anti-tank missile. It is an anti-tank missile. So Nag is designed for a specific purpose. In case of Agni, how many types of Agnis are there? How many types of Agni missiles that you know? So from Agni 1, we have this Agni 2, we have Agni 3, we have Agni 4, we have Agni 5. Agni Prime is being, or this often keeps coming in news. And then you have this Agni 6. Only these 3 are in service, or they are commissioned. The rest of them are still under trial. So Agni 1 to 3 are your in commission. Agni 4 is also not ICBM. ICBM is only this one. And Agni 6. Agni Prime, the range is quite less. It is around just 2000 km only. So it is testing some of the other critical components of the Agni missile. And what about the stages? So Agni 1 had 1 stage. These are having what, 2 stage. Agni 5 has 3 stage, and Agni 6 has 4 stage. This one again has 2 stage only. So these are your stages. These are the different stages of the Agni missile. And what is the type of fuel that we are using? Type of fuel we are using what? All solid. In all cases we are using solid fuels only. So in all the stages, that the fuel that we are using solid fuels only. So this is a brief background of the ICBMs, of Agni missile. So only these are your ICBMs. Now coming to Prithvi, there are 3 variants. So you have Prithvi 1, Prithvi 2, and you have this Prithvi 3. So in Prithvi, one is used by different, or they are being used by different agencies. So you just find it out which one is used by, let us say, Army, which one is used by Navy, which one is used by Air Force. Okay, they are short range ballistic missile only. So they are short range ballistic missiles. And see, Trishul and Akash are your SAMs that we have seen already. So now let us look at this hypersonic also, because it was in news. So this hypersonic glide vehicle. So after ballistic missiles, let us look at this hypersonic glide vehicle. So this was in news, so that is why we will cover this. Before we get to hypersonic, see, these ballistic missiles are, you would have seen the trajectory of the ballistic missile. What is the trajectory of the ballistic missile? So they are reaching what? They are reaching some orbit. So they reach to, in some cases it can reach to medium Earth orbit also. So if they are reaching to 2000 km, they enter into your medium Earth orbit, and after they go there, they could remain there for some time, and then they can deorbit. So they enter the orbit and then they deorbit also. So they are also referred as what? Fractional orbital bombardment. So they enter the orbit for some time, for a fractional second, or they enter the orbit for a very brief period. So that is why they are also called as fractional orbital bombardment system. So this question was asked, fractional orbital bombardment system. Now coming to the hypersonic, why this was in hypersonic. Why this was, why this is in news, why hypersonic was in news? Because China tested a hypersonic glide vehicle. So when China tested this hypersonic glide vehicle, it created a buzz around the globe. So what is this hypersonic glide vehicle? So in this hypersonic glide vehicle, the initial path is just like a ballistic missile only. So it will reach the earth's atmosphere, it will leave the earth's atmosphere, and then it will reach some altitude, and then it will fall. And then what happens, that when it enters the earth's atmosphere, because the speed is so high that it skips out of the earth's atmosphere, it has glides. It has glides means it has some wings. So because of those wings, so conventionally what you'll see, the rockets are what, they generally do not have wings. But these glide vehicles, these hypersonic glide vehicles, you'll see that their design is like a rocket also. This part is just like a rocket, and this part, like, they have wings just like aeroplanes. So because of that, when they enter the earth's atmosphere, they skip out, because the very high velocity, when they enter the earth's atmosphere, they skip out, and then they make another entry in the earth's atmosphere. And now when they make another entry at another point, they will glide like an aeroplane, and then they can hit the target. So the range of the hypersonic missiles is quite lot compared to even your ballistic missiles. So in case of ballistic missiles, you would have seen that the range is around 10,000 kilometer. Some of the sophisticated ones have a range of around 10,000 kilometer. In hypersonic, the range is very, very large. It is multiple times than your even your ballistic missiles. So that is the advantage of these hypersonic glide vehicles, and intercepting them is also very, very difficult. Why? Because they fly at very high speed. So in order to intercept them or stop them, we would need something which is faster than them also, which could be very, very difficult to do so. So that is why they were in news. See, these hypersonic missile, when they were tested by China, so then Russia also tested Zircon, USA also tested their missiles, India has also tested. So India is also having this type of technology, but this is in trial stage. So in India, so it is in a technology demonstrator state. It is at a technology demonstrator state. So later on we'll develop upon this also. So this is with respect to your missiles. Next, what we'll see, we'll look at, so this is the hypersonic technology demonstrator vehicle. So India has also successfully tested this technology. Now let us look at missile defense system. So in missile defense system, what do you need in missile defense system? So let us say this is a missile. This is a missile that has been launched, and this is the trajectory that it will follow, and it can hit a target. So what do we want? We do not want that this missile should hit the target. So we need to destroy it when it is in its path. So how can we destroy it? In order to destroy it, we need radars. So we have these space-based or air-based radars, and we have these ground-based radars. What is a radar? What is a radar? Do you know the difference between, let us say, radar and sonar? What is the difference between radar and sonar? What are radars? Radars and sonar, they both are used to detect what? To detect objects. To detect objects, but how they are detecting, that is different. So in radars, we are using radio waves. Yes, quite correct, Kishan. So we are using radio waves. Here we are using what? Sound waves. So this is radio wave detection and ranging. Sonar is sound wave navigation and ranging. So radio waves, because they can travel faster than the sound waves, their range is quite high. So their range can be about 3700 kilometers also. So they can detect things as far as for around 4000 kilometer. Here the range is around 400 kilometer only, and these are used for what? Air based targets or surface based targets. So surface, any object which is moving on the surface or any object which is moving in air can be detected by radars. Sonar is specifically used for underground detection. So if you have to detect, let us say, submarines, then we use sonar. If you have to detect aeroplanes or fighter aeroplanes or missiles, then we use radar. How do radars work? Radar work on a simple concept. So let us say it will send out radio waves. And if there is let us say an aeroplane here, so if there is an aeroplane here, it will send out radio waves. And what will happen? Some of the radio waves will be reflected by the body. So these radio waves will get reflected back, and these reflected back waves are detected. So by sending and receiving these signals, the radars know that where is the object and what is the possible speed of the object. Similar mechanism is used by your sonar also. So if we have to destroy this rocket, then we need to know the trajectory or the path of this rocket. How do we know the path of this object? So using help of radars. So we are using ground based radars, or we are using air based radars, or space based radars. And then we need to send what? Interceptor missiles. These interceptor missiles are your counter missiles. They could be launched either from ships, or they could be either launched from ground based systems. In case of your S-400, it is ground based system. So in S-400 you would have seen that there are trucks which carry the interceptor missiles. So these missiles that you're seeing here, they are your interceptor missiles, and this missile will destroy this missile. So this is basically the missile defense system. Now if we look at S-400, why it is considered to be the best missile defense system in the world? One of the prime reason is that it has a very wide range. Why S-400 is considered to be the best missile defense system? It is because it has very wide range. It can detect missiles coming from as far as 600 kilometers, and it can intercept 80 missiles simultaneously, or 80 not only missiles but any aerial targets simultaneously. It can detect and destroy 80 targets simultaneously, and all of this is done autonomously. So computers, they decide that which targets have to be destroyed by which type of interceptor missiles. And what is the another advantage is that the interceptor missiles, they travel at speed of 14 Machs. They are hypersonic. They travel at 14 Mach speed. Because they are traveling at 14 Mach speed, so they can destroy the enemy targets very quickly. So the interceptor missiles also, they are not only of one type, but they have different ranges. So interceptor missiles are of multiple types, from 40 kilometer to 400 kilometer range. So if the system detects that if it knows that it can destroy a target as far as 400 kilometers, so it will send a missile. It can destroy the target here also, or it can destroy a target very close to this point. So it can destroy it very close to the target also. So it has different interceptor missiles. Because of that, it has a very wide versatility. And India has purchased S-400 from Russia. So why India has purchased S-400 from Russia? So India will buy 5 such units. So one unit India has already received, and it has been placed in the western border, or in the Punjab border. So any missile which is coming from 600 kilometers from, let us say, west of India, it will reach even to Afghanistan, not only Pakistan, but we can know any missile which are coming from this region, and we can protect our air. So that is the advantage of this S-400. So India will be buying 5 such units, and it will cost around $5 billion. The uniqueness about this S-400 is also that it is ground based system. It is ground based system. So when it is ground based system, it can be deployed in many areas. So it can be deployed even in hilly areas, also in rough terrain also. So that is the advantage of S-400, and it is completely autonomous. It means that the computers, they detect that which target has to be destroyed by which interceptor missiles. And the advantage, or how it is better than even, let us say, this THAAD is what? THAAD is the air defense system of US, or a terminal high altitude air defense system. This is of USA. In THAAD, you will see that it cannot destroy very long range ballistic missiles. They can destroy short and intermediate range ballistic missiles, but it cannot destroy very long range ballistic missile. In cases of other air targets like your fighter planes and drones, it is not capable to destroy them. But in your S-400, it is capable to destroy any type of interceptor, any type of air targets. It can destroy fighter planes, it can destroy missiles, it can destroy cruise missile, it can destroy ballistic missile, it can destroy your drones also. So it can target multiple types of targets, and at the same time simultaneously it can destroy many targets at the same time. So because of that, S-400 is considered to be one of the best missile defense system of the world, and this was asked in your mains also. So in this slide, what you're seeing is Israel's Iron Dome missile defense system. So Israel's Iron Dome missile system is a very specific type of missile defense system. Why? Because they are intercepting mainly which type of targets? Short range rockets. So they fear what? That from this strip, so they will receive rockets, or they do receive rockets, and the target here is to destroy these short range rockets only. So Iron Dome is quite efficient, but it works only for mainly short range rockets only. So it cannot intercept, let us say, ballistic missile, but yes, it can intercept your other aerial targets like fighter aeroplanes or drones also. So in that way it is better than THAAD, but your S-400 is still better than even Iron Dome also. So in here you can see that it is mainly ground based system. So they have these radars, so through these radars they are able to know the path of the rocket, and they can destroy this. So last year these pictures were in circulation. So what is being shown here is that these are the interceptor missiles launched by your Iron Dome system, and they are destroying the targets. Yes. So it is a defense system only. So India is also trying to develop its own missile defense system. So it is a combination of what? Prithvi air defense system and advanced air defense system. So still in nascent stage, but we'll see this. So this is the design. So here we'll have the Prithvi will protect from in exosphere, that is beyond your 100-kilometer range, and this advanced air defense system inside the Earth's atmosphere. Now let us look at this submarines, or let us look at the assets of the Navy. So when you talk about submarines, here you need to know about that there are two types of submarines: diesel submarines and your nuclear submarines. So in diesel submarines, what are the types of submarines that India has? So in this slide you can see that India has these diesel submarines and India has nuclear submarines. Chakra class, it has been returned back to Russia. At present we have only this Arihant. So we have only INS Arihant. So whenever you see these naval ships, So they are named as INS, Indian Naval Ship. So INS Arihant. INS, we have only one nuclear submarine. We are developing one nuclear submarine that is called as INS Arighat, but this will come in future. So India at present has only one nuclear submarine, so it has around 15 diesel submarines. So Sindhu Ghosh class or Kilo class. So here you will see these terms: class, Shishumar class, or Kalvari class, Chakra class. So in this class there are different submarines. So this is a broader term. Classes are your broader term. In Sindhu Ghosh class you have Sindhu Raksha. So very recently this Sindhu Ratna has come back. So a few days back there was a news that Sindhu Ratna has come back from Russia after retrofitting. So it took a lot of time to retrofit. So Sindhu Ghosh is what? So these were some of the submarines that we got from Russia. The first was your Sindhu Ghosh only, then we have brought others also. Shishumar class, these were developed with the help of Germany in India. So there are 4 submarines in this. And in Kalvari or Scorpion class, so we are developing this with the help of France. In this is important from exam point of view. These are not very important. This was recently in news because of one Sindhu Ratna. It has come back after retrofitting. So this you should have just a basic idea. So it is what? A diesel submarine that we had got from Russia. Kalvari class, or this is the Scorpion class, and they are being developed under one project of Navy, which is called as Project 75. This Project 75, what is this Project 75? This is a 30-year program of Indian Navy in which will be developing these submarines. So under this Kalvari class only, you would keep hearing that we are developing we'll just come to this Kalvari class. So in Kalvari class, we have INS Kalvari, INS Khandari, INS Karanj, ILS Villa, INS Vagir, ILS Vakshir. So the first or the top 4 ones, they are now in commission. It means the Indian Navy has inducted it. These 2 are still, it is said that they are launched, or it has been launched. It means when it is launched, it means it is undergoing what? Trials. It is undergoing trials. So these names you should be aware because they were coming in news in past 1 year. So INS Kalvari, INS Khandari, INS Karanj, Villa, Vagiri and Vakshir. These Villa, Vagiri and Vakshirs, they have been named after fishes. They have been named after your fishes. So what is this Project 75? What is this Project 75? So this is a 30-year plan for indigenous submarine construction approved by the Cabinet Committee in 1999. So it started from 2000. It will continue till 2030. So it is a 30-year program, and India would develop 20 new submarines by 2012-15. Obviously these timelines have been breached, and subsequently India will make 12 of its own by 2030. So idea is that we will be developing around 24 submarines by 2030. So at present we have been only able to develop 6 submarines. So we will increase the fleet size to 24. So that is the objective of this Project 75. So you must remember that this Project 75 is about submarines. It is about development of submarines. Is this okay? Destroyers. So destroyers are your warships. Destroyers. So these are your warships. So this INS Chennai is your one of the warships. So they are different from your submarines. Obviously submarines, they travel below water, surface of water. These will travel on the surface of water, and here also what you'll see that destroyers are also classified under different classes. So you have this Rajput class, you have this Delhi class, and then you have this Kolkata class, so you have this Vishakhapatnam class, and this one is the most important one. Why? Because this project 15B is ongoing. This project 15B is ongoing. These projects are over now. These projects, project 15, project 15A are over. So in Kolkata class you have this INS Kolkata, Kochi and Chennai. So one of the interesting thing is, is that after the Rajput class, these destroyers are named after cities. These destroyers are named after cities. So this project 15 is over. This project 15A is also over. So we have developed this INS Kolkata, Kochi and Chennai. So Kolkata class is the largest ever destroyer to be built in India. This is the third and the last Kolkata class. The ranges are not very important, or what is the tonnage is not very important, but it is armed with supersonic BrahMos missile. In Kolkata class, so INS Chennai is the last one. INS Chennai is the largest destroyer to be built in this class. So this is your INS Chennai. So what is this project 15B? So this project 15B, here also the objective is that we will be developing what? Warships. So they are being developed at Mazgaon, at Mumbai, developed by Mazgaon Dock Shipbuilders. So the total of warships are planned. So these names would keep coming. INS Visakhapatnam is the first ship of the project, was delivered to Navy in November 2021. So INS Mormugao was launched in 2016. Launched in 2016 means that it is undergoing trials. INS Imphal was launched in 2019. INS Surat, it is under block erection, and it will be launched this current financial year. So it has still not been launched. So these are the different warships that are being developed under project 15B. So whenever you hear this project 15B, so you should remember that it is about destroyers, it is about warships. Okay, so in the project 15B, what we'll be installing? We'll be installing these BrahMos supersonic cruise missiles and surface to air missiles, that is the SAMs, and we'll also have these indigenous torpedo, and they will also have anti-submarine launch vehicles. So the role of the destroyers, that you know. Now aircraft carriers. So aircraft carrier, this INS Vikrant is in news. INS Vikrant. So the first aircraft carrier that India had was INS Vikrant only. So we have renamed, or the new one that we have developed, we have renamed it as INS Vikrant only. This INS Vikrant, it helped during the 1971 war. So in honor of that, we have renamed the latest aircraft carrier as INS Vikrant. So INS Virat, we had bought this from Britain. So we had got this from Britain, and we have returned them back. This INS Vikramaditya, we have got it from Russia. So at present, this is operational, and we have developed the INS Vikrant. So INS Vikramaditya was brought from Russia at a cost of around $2.3 billion. So we got it in 2003 and 4, but its refurbishment took around 8 to 9 years, and after that it was inducted in the Navy in 2013-14. Yes, Admiral not Gorbachev. So it was called by a different name, Gorshov. You just check the name. It was called as Admiral Gorshev. I'm not able to pronounce it properly. So let us look at this INS Vikrant. So INS Vikrant, one of the uniqueness about this INS Vikrant, that it is indigenous. It has been indigenously developed. When you say indigenously developed, it means that Gorshkov, yes, INS Gorshkov. So indigenously developed, it means that most of its component have been developed in India itself. But you should also remember or take a note that the engine has not been made by India. Engine we have got it from USA. General Electric has provided the engine for your INS Aryan. But 70% of the ship is has been developed indigenously. That is a unique feat with respect to INS Vikrant. So what we are saying, that it has a space for MiG fighter aircraft, so 34 fixed wing and rotary aircraft can be placed here. Then it also has space for helicopters and for indigenously built helicopters also. And the other uniqueness about this INS Vikrant is that it has compartment even for women officers. So traditionally what we have seen, that warships or these aircraft carriers did not have special compartments for women officers, but this one has special compartment for women officers also. So that is also the uniqueness. The motto of INS Vikrant has been taken from Rig Veda. So in Rig Veda, the motto of this, which it has picked from Rig Veda, is that I defeat those who fight me. I defeat those who fight me. The motto is reflective of the philosophy that India is not an aggressor country. It reflects that if you start a war or if you start a fight, then you're not going to win it. I'm not the one who will start the war or the fight, but if I fight, I'll definitely defeat you. So it shows the restraint also in our philosophy, that we are not an aggressor type of country. So this philosophy, you will see that it is present even in our nuclear doctrine also. So we have nuclear weapons, but the nuclear weapons that we came up with the nuclear doctrine. In the nuclear doctrine, we have pointed out to the countries that we are not going to use it for the first time. That is, we have that NFU policy, no first use policy. Even if we are attacked, then we'll attack. But even for smaller countries like Nepal or Bangladesh, those who are non-nuclear countries, we have assured them that we will not use nuclear weapons against them. So we have always tried to portray this in the international arena, that we are not an aggressor type of country. See, the speed, top knot speed or cruising speeds or endurance, they are not very important for you to remember. These technicalities are not very important for you to remember. See, from prelims point of view, the basic idea about aircraft carrier you should have. Okay. And the tonnage you can take a note that the tonnage is around 40,000 ton. Tonnage means what? The displacement capacity, or the weight essentially, or how much water it is displacing, the amount of water it is displacing. It is reflective of its capacity. So USA has some of the largest aircraft carriers. So what is the significance of the aircraft carrier? What do you think is significance of aircraft carriers? They are like a mobile military base. Yes, so they help, or they increase our range. They will increase the range. They help during land battles. In the 1971 war, INS Vikrant had helped. Pakistan had asked USA, so USA had moved their aircraft carrier in Indian Ocean. Then Indian Prime Minister at that point of time, Indira Gandhi, had asked Russia to move their aircraft carrier. So movement of aircraft carrier itself is a symbol that the country is entering in aggression mode, or it can be a symbol of, or it is entering into war. So it violates the sovereignty. It is also used to protect what? Some of the island territories. So India has island territories like your Andaman and Nicobar or Lakshadweep. It is also used to protect overseas assets. So in India we have companies like your ONGC, they have assets overseas also. So if you want to protect them, you need to have what? Aircraft carriers. So another aspect of aircraft carrier is that we need that the sea lines of communications. So the oils that we get from, let us say, from Russia or from Middle East, they travel through what? Through oceans only, through your commercial ships only. What if in the choke points like your Malacca Strait, if any country dominates the Malacca Strait, so can you ensure the free movement of the goods? So in order to ensure the openness of these choke points, a country should have aircraft carriers. So that is the significance. In fact, aircraft carriers are the strongest symbol of hard power. So that is why India wants to have these aircraft carriers. And the purpose of aircraft carrier is not only militaristic, but there is also humanitarian perspective, is that in case of disasters we can send these aircraft carriers because they have huge capacity, they can provide electricity, they can act as hospitals, they can provide medical aid or support. So that is the advantage of having aircraft carrier. So these are your assets of the Navy. So with respect to asset of Air Force, so in asset of Air Force, you just remember, have you read the new drone rules? Okay, what I'll do, let me just bring some questions also with respect to your defense technology. Okay, is this question visible to you? The 2022 question. 2022 question, that which one of the following statements best reflects the idea behind the fractional orbital bombardment system? Yes. Sorry for that. Layout. Let me just get it back. View. Print layout only. Yes, what is the answer in this case? What is the answer in this case? See, fractional orbital bombardment system. The catchword here is what? Bombardment. If it is bombardment, then it is of destructive nature. So hypersonic missile is launched into space to counter the asteroid approaching the Earth and explode it in space. So it is not about destruction of asteroid. It is not about destruction of asteroid. A spacecraft lands on another planet after making several orbits. So why will we use the term bombardment? So this is also not the answer. So next is, a spacecraft moves along a comet at the same speed and places a probe on its surface. So this is constructive in nature. This is constructive in nature. So why the term bombardment? So fractional orbital bombardment system is about, it is placing it in a stable orbit around Earth, and then it deorbits over a target on Earth. So this is what mainly your ballistic missiles. Is this clear? Okay, now let us look at this question number 2. So read this question. what is are the consequences of country becoming a member of the NSG? It will have access to the latest and most efficient nuclear technologies. Yes, others also please try. Please try. What could be the answer of this? Okay, so the answer in this case is your what it will have access to the latest and most efficient nuclear technologies. It automatically becomes a member of the treaty on the non-proliferation. So what we are saying that if you become a member of NSG, you become automatically a member of NPT. The reverse is true. In fact, you have to be a member of NPT to become a member of NSG. So this second statement is not correct. Only the first statement is correct. Only the first statement is correct. So the answer here is 1 only. So let us see some questions on missiles that has been asked previously. Yes, try this question. This one. Yes. Yes, so okay, so Agni 4 missile. Agni 4 missile. It is surface to surface. Yes, it is surface to surface. It is fueled by liquid propellant only. No, it is solid. It is solid. It is not fueled by liquid. It can deliver 1 ton nuclear warhead over about 7,500 kilometer away. So Agni 4, 7,500 kilometer means what? It is here it is saying that it is ICBM. But is Agni 4 ICBM? Is Agni 4 ICBM? It is not an ICBM. So this is incorrect and this is also incorrect. So the correct answer is this only. In missile defense system, try this question. Yes, THAAD, sometimes seen in news. It is an American anti-missile system. In submarines, we do not have much questions. INS Astradhani, that we'll see later. Okay, now coming back to, let us say this. I'll just add one more slide and let us just quickly do this also, that small topic of IPR. So what we'll now look at is IPR. So IPR, why IPR is in news? So IPR, what is IPR? IPR, what is IPR? What is IPR? Okay, IPR is your intellectual property rights. Now, why? What are the things that are in news with respect to IPR? So, in IPR, what do you know about licensing? And this section 3D, evergreening. So this section 3D was in news. Why this was in news? Why this was in news? Why section 3D was in news? Section 3D. So India has the Indian Patent Act. Indian Patent Act of 1970. Indian Patent Act of 1970, and in that we have this section 3D. So this section 3D is about evergreening. Why this was in news? Why this was in news? So there is a particular drug of Johnson and Johnson which is known as bedaquiline. This is bedaquiline. Have you come across this bedaquiline? So bedaquiline is used for treatment of a particular kind of TB. So TB is caused by bacteria. TB is caused by bacteria, Mycobacterium. It is caused by Bacillus Mycobacterium. And what is happening in TB? That TB is becoming resistant to some of the antibiotics that we have developed. So TB has become multi-drug resistant, or it has become the next level of resistance is extensive drug resistance. So for MDR TB, if a person gets infected with multi-drug resistant TB, then the only medicine that is quite effective is bedaquiline. But bedaquiline is a patented product of Johnson and Johnson. Bedaquiline is a patented product of Johnson and Johnson, and its patent is going to expire in July 2023. Its patent is going to expire in July 2023. So what had Johnson and Johnson did? What they did is that they had filed for a fresh patent, and they had just tweaked the design of bedaquiline, and they had filed for fresh patent. However, the Indian Patent Office denied patent to bedaquiline, citing section 3D of the Indian Patent Act. Have you come across this in the news? This is quite important for this year's prelim and probably for next year also. Do you know what is section 3D? What is section 3D? In the intellectual property rights? Okay, what is a patent first of all? What do you mean by patent? Patents are of two types. One patent is product patent, and the other patent is your process patent. Can you tell me the difference between these two? Then let us see. Then we'll come to this. So Indian Patent Act is providing which type of patent. So let us first understand what is process patent and what is product patent, and then we'll come to this news item that Indian Patent Office denied patent to Johnson and Johnson with respect to bedaquiline. So this section 3D of the Indian Patent Act checks for evergreening. So what is patent? Patent, as you are saying, it is providing exclusive right to the creator. So patents are intellectual property rights. So they provide the inventors, or they provide the creation of mind some protection for a specific period only. It is not that once you have got a patent, it will continue for entire existence of that product. It comes with a sunset clause or a time clause only. So patents in India, they are provided for 20 years. So once you have got a patent, so you have a protection for 20 years only. Can you tell me the difference between process patent and product patent? Can you tell the difference? Process patent, let us take any medicine. Let us say there is medicine, this medicine D, and it can be made by different processes: process 1, process 2, process 3, or process 4. So if you have got a process patent, it means that nobody can use this. Let us say you have got a patent for process patent for P1. So nobody can use P1 to make this medicine D, but somebody can use P2 as a method to produce D. It means that it keeps the door open for what? Reverse engineering. So India from 1970 till 2005 had process patent only. India had only process patent only. India did not allow product patent. So it kept open the doors for reverse engineering. So India became a hub of generic medicine. When you have product patent, it means if a company has a product patent for this medicine D, then nobody other than the patent holder can make this medicine D from any process. It means nobody can make this medicine itself. So there is no question of reverse engineering. Are you able to get this? So India adopted product patent in 2005 only. In 2005, so the major amendment in your Indian Patent Act was brought about in 2005. So we started giving product patent also. But we also included some protection mechanism also in our law. So we have added section 3D. So we have added section 3D in the Indian Patent Act. So this 3D checks evergreening of patents. What do you mean by evergreening of patents? So questions in both prelims and mains have come in on this concept, evergreening of patents. What do you understand by evergreening of patents? Yes, anybody? Evergreening of patents means that yes, we somehow they will tweak the design, the companies tweak the design, and they will file for fresh patent, and they will try to extend the patent period, so they will get exclusive rights over those products. So they are trying to increase this time period. So evergreening is that process. So in our law we have provided provisions which checks evergreening. So in section 3D of our Indian Patent Act, we have provisions to check evergreening. So how this bedaquiline was denied patent? So in section 3D we have a part which says that new forms of known products, new form of known product cannot be patented. New forms of the known product cannot be patented. So what see this in this the classical example was the 2000 in 2012 2012. I'll just check the date. So there was this famous Novartis case. Novartis case. So Novartis is a Swiss pharma company. So Novartis had done what? They had a patent for an anti-cancer drug, which is imatinib, and its time period was getting over. So what they did, they tweaked the design of imatinib, and they said that they have got a new medicine, and they named it as Glivec, and they filed patent for Glivec. However, the Indian Patent Office denied, saying that it is nothing but a new form of known substance, that is imatinib, without increased efficacy of this drug. So they denied the patent, and Novartis went to court in Supreme Court. However, they lost the case. So Supreme Court gave the decision in favor of the Indian Patent Office itself. So this was the famous case with respect to evergreening. So again, with respect to bedaquiline also, Johnson and Johnson, they just tweaked the design and they had filed for fresh patent, but the Indian Patent Office denied patent to Johnson and Johnson. So in July 2023, their patent will get over, and this bedaquiline will become cheaper. Why do we want to make it cheaper? If it becomes cheaper, then it will help us to fight this scenario, that it will provide help or succor to the patients, those who are suffering from multi-drug resistant TB. So bedaquiline will become cheaper. So at present, those who are suffering from multi-drug resistant TB, we have to give them this patented drug, so which is costly. Okay, so it is increasing our cost for fighting TB. So this will help in that scenario. So that is why this section 3D is important, and you should remember this section 3D. Another important section that you should remember, I'll just take another slide. Another important section is your section 84. Another important section in the Indian patent law is this section 84, which talks about what? Compulsory licensing. Compulsory licensing. So let us just understand this through an example of what is this compulsory licensing. SII, what is SII? What is SII? What is SII? Yes, Serum Institute. So the SII is Serum Institute of India. Has Serum Institute of India invented Covishield? Has it invented Covishield? Has Serum Institute of India invented Covishield? Serum Institute of India has not invented Covishield. It is a manufacturer of Covishield. The inventors are your AstraZeneca and Oxford University. They have developed Covishield. And SII is manufacturing it. SIA is manufacturing it. So So they are the patent holder. They have the patent. They are the patent holder. Now can you tell me that if AstraZeneca and Oxford are the patent holder, how is SII able to manufacture Covishield? They are the patent holder of the Covishield vaccine. If you are a patent holder, only you should be able to manufacture the vaccine. How is SII able to manufacture it? So AstraZeneca has given SII what is called as voluntary license. Voluntary license. Voluntary license. It means they are the patent holder. They have licensed a third party. They have licensed the third party to produce the vaccine, and in return SII will give what? Royalty to your AstraZeneca. Is this part clear? But what if in case they would not have agreed to give voluntary licensing? If they would have denied licensing to SII, could SII still have produced or manufactured Covishield? If they had, AstraZeneca would not have given license to SII, could still SII produce or manufacture Covishield? Yes. So in such scenarios, if the patent holder is not willing to give voluntary license to a third party, then government of India can intervene, and they will ask or they will force the AstraZeneca to give compulsory licensing to SII. But in rare scenarios only, in case of public health emergency. So in case of public health emergency like COVID, government can ask or invoke the compulsory licensing clause, or in case of a situation where these drug companies are not supplying sufficient quantities of life-saving drug, or if the price of the life-saving drug is very high, then in that case also, if government feels that it is related to public health, then government can invoke compulsory licensing. Compulsory licensing, it means that these patent holders will have to give the license to a third party, and in return they will get a royalty, but this royalty would be negotiated by the government also. So the famous compulsory licensing case was your this Natco case. Natco is an Indian generic pharma drug manufacturer. So there is this German pharma company called as Bayer. So Bayer had developed a anti-cancer drug, and the cost of the anti-cancer drug per patient per year used to reach around rupees 10 lakh crore, rupees 10 lakh per patient. And so government realized that they had to make this medicine cheaper, so they gave what? Compulsory licensing to Natco. So Natco was able to manufacture this drug, and the cost had now reduced to just few thousands of rupees, or 20 to 25,000 of rupees per patient per year. So because of that, so there was criticism also that if government keeps on using compulsory licensing, then the motivation or incentive of these companies to develop such type of drugs would be diminished. But these provisions are used very rarely. Are you able to understand this idea of compulsory licensing? So in the Indian law itself, we have provisions for compulsory licensing. So if you have any doubts, you can ask. If you have any doubts, you can ask. So read a little bit about also the Copyright Act of 1957. Copyright Act of 1957. And with respect to GI Act, in Copyright Act, what is the protection period? What is the protection period in copyright? In copyright, you should remember during the lifetime of the author and 60 years beyond his or her death. In GI Act, the protection period is 10 years, and the uniqueness about the GI Act is that it can be refiled, or you can get a renewal of the protection period also. So read about the GI Act and find out some of the latest items that has been provided with GI tag. Okay, so best of luck for the upcoming exam. Best of luck for the upcoming exam. And see, in prelims, now I know this is a high time, so I wouldn't give you any suggestion. Just you know how to attempt papers. You just have to maintain your cool and keep in mind CSAT paper also. So relax your mind during the 3 hours gap and attempt the CSAT paper well. Okay then, thank you all. I'll close the session then.